Hello, everyone. Welcome back to welcome back to SAT Math Question of the Day. Please read the question, pause, and come back. And today's Throwback Thursday. At the end, we go back to an old SAT question from 20 years ago. Okay, here we go. Calculator section from the old test. We have a table for the polynomial function. Oh, the table shows some of the values of x and their corresponding values of the f of x. Which of the following could be the graph of y equals f of x? Oh, it's a polynomial, but they're all polynomials. So they didn't throw a linear question in. They should have. Oh, the x is, well, every point that's on here has to be on the graph. So let's just check for, I don't know, gut feeling. 1, 5. 1, 5. Well, 1, 5 is not on. Am I reading this right? 1, 5. Forget it. 1, 5. There's no way. 1, no way. 1, maybe. Yeah, that looks good. No way. So it looks like this one. Just check this one. I don't know. My gut feel was just to check the last one for some reason. I don't know why. Um,
Well,
uh,
you got a lucky tummy.
I don't know. I just had a gut feel that we should check the last one.
Yeah.
Um,
My feeling was to check the first one,
you're so
and I
normal.
didn't do, and it took you fewer steps.
Yeah, I don't know why. I don't know why. I just have this gut feel. But what are we checking
Yeah.
anyway? We're checking for ordered pair, what called ordered pairs. We're checking to see if -4, 0. Oh, sorry. Right, meter. We're checking if -4, 0 is on the graph. X is equal to -4, y is equal to 0. -1, 3 is on the graph, and whether 1, comma,
Hmm.
5 is on the graph. And that's it. Calculator's not going to help here. Um, oh, really? 0, -4 has two spots on. Well, oh, I see. I read it wrong. Oh, yeah. -4, 0. -4, 0. Yeah. Yeah. Oh, yeah. -4, 0 has two. Yeah. This is
There
-4,
are
0.
two
There
graphs
are two graphs with -4,
of the
0.
four in
Yeah.
which the graph has a point that has on the graph the point with coordinates -4, comma 0.
Right. Yeah. Yeah.
And then to solve the problem, you could solve the problem by choosing those two graphs and then eliminating the one that's not the answer by looking at one of the other sides. You could do it very easily by realizing that the other values of f are all positive,
Right. Yeah. Yeah.
and the x values are all to the right of the -4,
Yeah.
right?
Yeah.
And so the C course, you have the graph does not go into the positive region after -4.
Yeah.
Whereas the correct answer, the graph is on the positive half of the plane to the right of -4.
Right. Yeah.
But your gut feeling of choosing the last of them actually lets you resolve the question and answer it immediately
Yeah. Yeah. They must have.
after one
Yeah.
exam.
Yeah. Maybe my gut feel was that
So that was
they
a
would.
lucky gut.
No, but the other thing, I mean, it's maybe the brain processes information in different ways, and maybe
Oh,
maybe in my subconscious, I said, well, if they made it this one, it would be too easy. Why would they
oh,
not? If you were designing the
yeah.
test, of course you would make the first one have two possible solutions. Of course you would. This is also question
And
6.
the second one is two possibilities.
Yeah, I know. See, this is question
Yeah,
6. You're starting to get into the test now. And if they
yeah.
make the questions easier as the questions go on, in fact, the book we were using for Throwback Thursday lists the difficulty of the questions in line, so we can quickly see a pattern if the
Oh.
difficulty of the questions go
So
up.
I wonder if I wonder if it's a helpful strategy that when there's a choice when they give a sequence of things that should be checked, they give the ones that result in less checking to the right.
You would.
At the end of because they expect people will check the first ones first.
Right. Yeah.
And I wonder if they designed it so checking the first ones require more work.
Yeah. Yeah. You would think that. I mean, if you were
Could
making a
be.
test, you would think.
Well, we could someone could survey SAT questions and see if they actually, if we could check if that's.
We're not going to do it, but yeah, someone.
We're not going to do it. No, you could do it on the web.
Yeah, someone can do it. Okay, so I think we're done with this, but you do have to know the similar. I think a few days ago, you do have to know this notation of this f of x. See, they didn't use y. Look at that. Is that inconsistent, Seth? Is that you have PhD? We're going to introduce that later. You have a PhD in math. Is there a problem here in that they have f of x and then they don't use f of x here? They only introduce y. They only introduce y, but y is a variable that has not been technically defined. Or am I going over?
No.
Am I going over?
The y refers to the graph.
But where does it say?
Right, and then the y refers to the graph.
Right.
The table doesn't have a y in it; it has an f. But the text, the last three words of the text say y equals f of x.
I missed that. Oh, you're right. I'm sorry. I missed that. You're right. So it is consistent. Y equals f of x. Yeah. So generally, generally, when you see an f of x, it's unless the question's really out to trick you or is in more subtlety, it generally equals the output of the function or y. Generally, that's a general common, covers you almost all the time. They're really interchangeable. It's the output of the function. It's on the chart, it's the horizontal point, the horizontal level of a chart. Okay, so I think we're done with this, right?
Yeah, we're done.
Yeah, okay. So we could just move into Throwback Thursday. So our Throwback Thursday question of the day. We went back to a review book from that's copyright 2003. So it's about 21 years old, and this is before the test was really a test that tested what you knew in school. These questions had a little snaz to them. Maybe they were a little more complicated. Some of them were. So let's see if this one is. Unfortunately, when I looked at it and choosing it, I already saw the answer. This is marked as a difficulty level 5. Back then, they would mark the difficulty levels of the questions in the review book. And this is an actual book from the SAT. Okay, here we go. Our Throwback Thursday question of the day. So let's do it. Okay.
Oh, wow.
So, again, unfortunately, I know the answer, but I could still try to do it. The figure above, so you have to do some visualization here. Let's move this over. Wait, what am I doing? Okay, I'll just leave. Okay, the figure above shows a cylinder with radius 2. Oh, we could draw that in. Can't we? Oh, 2. 2. Oh, it's a height of 5. Oh, let's put that in also.
Yeah.
Okay, if points A and B lie on the circumference of the top and the bottom of the cylinder respectively, what is the greatest possible straight line distance? Whoa. Well, one straight line distance would be 5, wouldn't it? If this was B prime, that would be 5. But it's not, it's on the other side, so don't you draw a right triangle? Yeah, you could do that. Sure. You can do that. Yeah, you draw a right triangle. I'm sorry, this leg is not straight. I know. Right? You go down, then you go across, and then you go. The answer is this distance. That seems to be the maximum you can be. You can't get further than that, right? Hypotenuse of a triangle is the biggest side in a right triangle, and then the right angle is here. So you require some visualization, doesn't it?
Yeah, yeah,
Yeah.
yeah,
If people have taken geometry with the old pyramid, you've done similar things with the pyramids, with the
yeah.
slant height and visualizing the right triangle inside the pyramid. So now that we visualize it, it seems like it's the hypotenuse of that right triangle, and you have to know the Pythagorean theorem. So it's a squared plus b squared is c squared, 5 and 2. So it's 25 plus 4 is c
No,
squared.
nope.
Oh, shoot. Oh, man, no way. No way. They did it. They did it. They did it. Oh, no. God. Oh, man. Oh, no way. Oh, I hate them. I hate them. I hate them. I bet half. That's probably why many people. Oh, I hate that. How many, raise your hand, Seth, you're included. How many, raise your hand if at some point in your life you use the radius instead of the diameter, or the diameter instead of the radius in a geometry problem? Everybody, raise your hand.
I've done that, but not today.
You gotta raise your hand. You're not gonna raise your hand? Okay, yeah.
But not today.
Not to. Oh, because you were. How did you not make that problem? How did you avoid that mistake today? Was that
Because you have to know there's a difference in radius and diameter.
We all know the difference between radius.
Well, you have to know. You have to use it. You have to be awake.
Is that because
That's
you were watching
because
me?
just because I'm drinking coffee from my MIT cup.
Yeah, forget this. That's ridiculous to say. No. Is it because you were watching me make the mistake and you caught it?
No, I solved the problem long before you talked.
Okay. Anyway, I already knew the answer.
My problem.
Yeah, what was your
problem? What I struggled with was adding 25 and 16 and thinking mistakenly it was 49. But that's my mistake.
Yeah, but that wasn't a choice, right?
Oh, yes. Yeah, you have to be careful in the adding. The 25 and 16. You have to 5 and 6 is 1. With a carry of 10, and you have to remember to add the carry to the 2 and the 1 to get 41.
Right, but thankfully that if you add those wrong, it's not one of the choices. By the way,
No, the thing is, you drew the radius. Yeah, certainly.
I drew the radius.
You drew the radius. That's beautiful.
Right.
Yeah, you drew a beautiful radius, right?
And
there it is. A beautiful radius.
Nice radius.
And you drew a beautiful diameter.
I know.
They're different.
I know. Please.
Of course, the perspective view, when this is projected into a planar drawing, that green line is approximately the same length as the blue line.
What green line?
But in 3 dimensions, right, the green line is half the length of the blue line.
Right. When said the green line, you mean the
the green line marks the radius, and the blue line on the bottom of the circle marks a diameter.
Right. Yeah, there's the green line. Well, we want a nice dark green line. There's the green line. There's the green line.
Yeah.
Oh yeah. Now I would have caught myself, but in a totally cheating way. Because when I chose this question, I noticed the answer was E. If I did 25 plus 4, I would have gotten 29. And then I would have said, but I already know the answers. Now, unfortunately, on the test, when you're taking the test, you never know what the answer is. Okay, so that's when I would have caught it. Oh, I feel so.
Yeah.
Oh, wow. Yeah, you got to really be careful. And now the book doesn't distinguish. Well, we don't know. They say it's difficulty level 5, but I wonder whether they decided that based on how well people made a mistake, because some people would have made the mistake I made and still got it wrong. We don't know when they sometimes they tell you the percent of people who get questions right and wrong.
Yeah.
So anyway, that's how you do it. But the hard, that's a stupid mistake. But the more difficult part of it is visualizing it.
Yeah.
Which is not that easy, and it is question 25, and it was marked difficulty level 5. And back then, the SAT had 3 math sections that they interspersed them. It was a whole different type of test. and this was 25 questions in 30 minutes. You were expected to do 25 questions in 30 minutes. This was the last question.
Well, I think you gave a nice justification for the use of the right triangle.
Yeah, yeah.
That the longest distance would be realized by the hypotenuse of one of the right triangles. One of the right triangles whose vertical side is starts at A and falls downward, and whose horizontal side comes out of B and is on the bottom face of the cube, bottom face of the cylinder. All of those pairs of blue lines. Let me draw another pair of lines. A case of that when
getting into this problem.
A case of that when it's not, it's not the longest possible line. Take this. Imagine this line here. That's along the side. It's along the bottom.
Yep.
So it is perpendicular. It is perpendicular to the blue line. There it is. And the hypotenuse goes from here to here. So this was also a right triangle.
Yeah.
But what's the difference between the purple right triangle and the blue right triangle? Well, the difference is the purple one has a shorter base than the blue one.
Right.
And now, if you have a circle, you pick any point on the circumference of the circle. The maximum length. The maximum distance to another point on the circle is completely opposite, which is the diameter. So that's the maximum distance is the point that is on a diameter coming out of this point.
Right.
So it is the diameter on the bottom that gives you the right triangle whose hypotenuse is longest.
Yeah. Yeah, so Seth drew it in. It is actually you can draw.
Well, the thing is, this in math you have to have a rational reason, a rational justification for why the geometry that you pick satisfies or is the answer to the question that's asked.
Right.
The question that's asked is about the longest line from a point on the circumference of the top circle to a point on the circumference of the bottom circle. But and you have to justify that the longest line of that sort is characterized by the hypotenuse of some right triangle whose height is the height of the cylinder and whose base is a diameter of the cylinder.
Okay, well that's all proving it, but Seth drew it in pink.
Well, the mathematics is the way people know things in math are true is by proving them.
Absolutely.
People might guess the truth of things. They might be right.
Right.
But in math, we have the opportunity to be absolutely sure of many mathematical facts. We become absolutely sure when we have proved them.
That's exactly right, and that's why one of our questions of the day is the difference between doing it as a question of the SAT and in school. And trust me, Seth, nobody is going to be sitting there proving this. You're just going to do.
Well, I think what happens is people who have more practice, more of a taste, more of an understanding of math, will understand and foresee the ideas that might the ideas that tend to be motivations for proofs,
Okay, but let's get back to
which
this.
are good guesses. So people, the more math you do, the more you've practiced, the more you encounter it, and in fact, the more you like it, the better are your guesses.
Right. So I have two comments on this question. Two things to say. One, the way Seth drew this big triangle. Let me offer a more way that may be a little less confusing. I went directly from the top to the bottom, right? My blue line, this one. But what
Yeah,
Seth essentially did was said, okay, let's just move this slightly. Let's just, instead of going top vertical, let's just move it just slightly this way. Okay? So, so this
uh,
yellow line, this orange line is really not much bigger than the blue line, but it is on the bottom of the circle. See? And that's essentially the same right triangle. Seth, maybe you could see it better. And then there's this little radius, right? And then you realize this is also a right triangle, but this is clearly not the biggest distance
yeah,
between A and B double prime. So what do?
yeah, yeah,
You just keep marching around until you realize that until you get this thing, this thing as big as possible, and you realize, oh,
yeah,
if I go all the way to the other side, that just makes everything the biggest, and that's how you get the answer.
yeah.
Now, the other thing that I just want to mention, which I did subtly, but I personally think is a really powerful technique, is when I first saw this problem, like many problems, I had no idea how to do it. Seth has the PhD in methane, well, not only, but I have a PhD in mechanical engineering. I didn't see exactly how to do this. So what I started doing was playing with the problem. I just wanted to get something. I just wanted to figure something out. So I said, look, I don't know how it's the largest distance, but let me look at any distance that's super easy for me to calculate. And a super easy distance is just a vertical line. It's just a vertical line. I could do that. I'm just playing with the problem. Play
Hmm.
with the problem. I played with it. I said, well, at least I could see this is 5, and that maybe it looks like it's going to be bigger. And then it occurred to me when I was playing with the problem how to do it. I didn't go
Hmm.
directly in. I didn't say, well, it's clearly
Oh
the
no, yeah,
diagonal. I didn't. Did you
absolutely
see
right.
me say that? No, I played with the problem. Just
Yeah.
play with the
Well,
problem.
I played it with the problem too, and it's somewhat different. My approach was that I knew that the line had to be in some plane that intersected the cylinder. So then I thought of all the vertical planes, all of the all of the not for yeah all the vertical planes that intersect the cylinder. Each such plane intersects the cylinder in a rectangle, and that the longest line from one point on the top circle to a point on the bottom circle is the diagonal of one of those rectangles.
Okay.
And so I thought of what would be the biggest rectangle you can
Right.
get, and that biggest rectangle is the rectangle you get by looking at the cylinder from the side, a side view. We're looking at the cylinder from the side. When you look at the cylinder from the side, what you see is a side view. Uh, I'll do it in black. The side view is like this. You see just the top and the bottom collapse to a line.
Mm.
The the two of the verticals on the side collapse to these lines, and then the cylinder is before and above, is in front and below. So this is the largest rectangle that will intersect the cylinder, and then I figured out what the lengths of the sides of this largest rectangle is. Well, the bottom we have 2 and 2, So the bottom is 4, it's length 4, and the top and the vertical is the height of the rectangle, which is 5.
Hmm.
So that's where I got the 4 and the 5. And then I have to do the calculation of what is the hypotenuse
Yeah.
of a triangle. And so they, 25 plus 16. What's that? 25 plus 16. What's 25 plus 16?
Yeah,
Is it 31? Is it?
Yeah. Well,
it's 29.
Calculator, so you're allowed to use a calculator.
Maybe use a calculator. 25. I didn't use a pencil. 25. Let's see. If I wrote it down, I was.
No, but you only have to
do it more easily. It's 1, 20, 41 is a square there. Yeah.
But you only have to use last digit math. If you have a 25 and a 16, you only do the 1, and then you only look at the other one what has a square root. Well, actually, wait, you only see the 1 square root of 1. This is 9 squared, 25, 49. This is 1. Last digit math can help. So you saw a cross-section. Use your visualize the cross-section. So in terms of visualizing things, we have to make a big suggestion. We are not being paid by these people. Also, I think it's a free website. If you want to visualize anything in geometry, go to this website, and you know what I'm going to say, Seth, right? And I'm going to get the spelling right. Algebra.
Mm-hmm.
If you want to visualize anything like type in your browser, cross-section of a cylinder, GeoGebra. Wow. I mean, yeah. Or rectangular cross-section of a cylinder, GeoGebra, you will see. People will have done projects, and you can play with things, and highly recommended if you want to visualize things in geometry.
Yeah.
So, I think we've beaten everything to the death here. So, it turns out this was the hardest question on section 1. And just to do a quick look at the answers, I believe that the numbers do back then in 2003, the questions did go up in difficulty, starting with the first question. They generally did. Although they did make question 15 of question 5, but generally they go up. But question 15 out of 25 was rated difficulty 5, and then it went back down, and they do seem to go up linearly. Okay, but that was back in 2003. We don't know what they're doing now. Anyway, so we're done. So I'm Joel. I have a PhD in mechanical engineering. So my brother Seth here at a PhD in math from MIT. We're here to hopefully show you ways to approach SAT math questions. This is a rich question because there are different ways to approach it. Playing with the problem, critical. We never asked those questions on the first. Remember our 4 questions, but forget it. It's too late.
I forget. Too late.
We've been there, done that. The wave has passed. And we try to meet every day to bring a SAT math question and to go over a SAT math question, to offer different ways to go over it in terms of studying. Go and practice as many questions as you can and practice on your weak points. Khan Academy offers a great number of questions sorted by problem type. So you can go there and practice on the topics that you need, that you want to get better at. And now, post 2016, the test really tests more of what you learned in school rather than weird questions like this. So that this question wasn't that weird. And that's basically it, right? And please dislike our videos. Comments are encouraged. People are starting to leave more comments. Thank you in advance for everyone who's leaving a comment or even thinking of leaving a comment. And if you have any SAT math questions, please email them to us at satmathquestionoftheday@gmail.com. And we will do it together, instead of one of these past test questions. Okay, everyone. So have a great day. Bye.
Bye.